Alright, so this will take a quick look at some of the basics with angles. So the first thing is just put in a definition to an angle. What it is, it's going to be um, two rays that share a common endpoint. And those of you that have been around some of this stuff before, you might remember that endpoint is actually called a vertex. So we look at this particular angle, the vertex is called B. The size of this angle would be ray BA. Notice I put the ray over the top and ray BC. And there's a few different names that we could give this particular angle. The two that are probably the most obvious to you, angle ABC and angle CBA, um, right? And again, that little symbol in front, right, that means angle. That's the symbol for angle. And that's one of the beauties of all this geometry stuff is I can use shortcuts and whatnot. Um, the other ways I could name it, there's a 1 in there, so I could call it angle 1, or I could name it by the vertex in this particular case and call it angle B. So just in case, we can shade the interior with some dots. All right, just a quick reminder, anything between the two rays is called the interior of the angle. All right, so adjacent angles. So probably the best way to kind of think about adjacent angles, so here's angle 1, and then here's angle 2. These are two that are adjacent to each other. Notice they share a common vertex and they also share a common side versus non-adjacent. If we had that one and this one, they share a vertex, but now all of a sudden they don't share a side, so they're no longer adjacent to each other. So for adjacent, they need to share common side and vertex. All right. So we go down here to the next example. Talk about vertical angles. Now, despite the name vertical, it doesn't always have to be up and down. Um, Probably the best way to look at this are angles that are across from each other when two lines intersect. Notice in that very next picture, that's two lines intersecting, okay? And so all of a sudden, some vertical angles, you got 2 and 4 that go together. So 2 and 4, those are probably the most obvious because they are up and down. But 1 and 3 are also considered vertical angles because they're across from each other when those two lines are intersecting. Congruent angles are angles with equal measures. So where that comes into play for us, actually up here, something to note about vertical angles. Vertical angles are congruent. And that's definitely worth noting. That new symbol right there, that might be new to you. Again, this means congruent. And as we just saw, congruent means basically have equal measures. So a right angle, this is probably not new to you. It's an angle that measures 90 degrees. And just as a quick reminder, if you see an angle with that little box in it, that's our indicator that we have a right angle. Acute angles are angles that are less than 90. And then an obtuse, that's an angle between 90 degrees and 180 degrees. Right. Complementary would be two angles that sum to 90 degrees. Best way that I can remember that one are that complements are always the right thing to give. And when I hear the word right, I think of that 90 degrees. Uh, Supplementary will be two angles that sum to 180. Good way, another quick mnemonic device to tell the difference between the two. Um, More P's equals more degrees. So, in other words, you look at complementary has 1p, supplementary has 2, and so you can kind of play it out that way. So, we're going to use some of these properties with congruent angles and supplementary and complementary to start solving some problems, to start using some of our algebra. So you look at the next page. The 6x and the 42, here's an example of those vertical angles. And we know vertical angles are congruent. So what we can do is we can actually set up 6x equal to 42. Take a quick second, divide both sides by 7, and say x equals 7. You look at number 2, here these two angles, when you put them together, that's a straight line. Remember, those lines, that's 180 degrees. So in other words, we have a couple of supplementary angles here. Remember, supplementary angles sum to 180. So in other words, x plus 100 equals 180. And then, so the missing chunk there, x is going to be 80 degrees. Now some of your pictures are going to involve both of those. All right, so if we take a look at number 3, right away the x and the 120 we can see form a line. So x plus 120 equals 180, which means x is equal to 60. And then if we look closely in there, we get this relationship, the 2i and the 20, right? We have two lines intersecting. The red line and the blue line are intersecting, which means we get vertical angles. And 2i and 20 happen to be vertical angles. And that means that they are congruent. Notice I marked it right there with that red kind of arc with the dashes on it. That's an indicator of congruence. So we can set those two pieces equal to each other, divide both sides by 2, and we see that y equals 60. All right, a little bit more involved picture, but now listen, we have 3 lines intersecting, which, don't let that throw you for a loop. Really, all that's going to give us is even more sets of vertical angles. You just got to find the right pieces that go together. So maybe we start right here with the 50. Across from the 50 is the 5x. So we can go ahead and set 50 equal to 5x. Divide both sides by 5. X equals 10. And then if we look closely, we see the y is across from the 35. And notice I mark it a little bit differently than I did with the red markings. Just to indicate, again, the y and the 35 are also vertical. They're across from each other, but they're a different set of angles than the red ones that I marked initially in this problem. Here, we're not actually going to have to solve anything. Y equals 35, and I'm done. Something that's missing down here, number 5, that we're going to need to solve this one, because right now we can't do anything with it. Forgot to put that in originally. But what we see is that right angle, right? We see that 90 degrees, and here we have two angles that are going to sum to 90, and that's what we called complements, complementary angles. So in other words, x plus 60 equals 90, and so the missing piece there is 30, right, if you subtract 60 from both sides. And then finally, number 6, again, we're in the same boat. We have these complementary angles, and although the temptation might be to just set these two things equal, those aren't vertical angles, right? If you look, those aren't across from each other. They're adjacent. They're right next to each other. So what we're going to have to use to solve this is our complementary angles definition. So 9x plus 45 equals 90. And so to solve this one, two-step equation here. Subtract 45 from both sides. So 9x equals 45. Divide both sides by 9, which means x equals